Oh, hello, Margarita. Hello. Well, good morning. This is the online event about Herschel project that you know that NASA begins to organize at the spring equinox. And we are very happy that we have many countries participating in the project, about more than 30 countries. And here we have 23 countries that will be participate today. This is an activity that we believe it is interesting because it is possible to show in a simple way the infrared radiation, that it is not easy that the people have some special activities in the school with this kind of radiation. Then it is a simple possibility that for a primary, secondary school, it is not difficult. Of course, you need to have a prism. In some cases, I know that it was in some countries very difficult to find it. But we can see here some example of teachers that they try to produce themselves the prism when they didn't have it. Also, in some cases, the thermometers was difficult to have them. And in some cases, the people have to use only one and to repeat the experiment several times. It's not the same. But in any case, I think that it was a proof that the creativity and when a teacher and a group of students want to test and to try to do one concept activity, they really can do it. Then I think this is very, very important because here is a connection that we collect a set of students and teachers that they are very active, very creative, very interested and motivated for science. And also, I hope motivating other people in their schools. Then, basically, the idea is that if you want, you can do it. Then, the idea is to try to insist and continues with the work and the effort. Then, I would like to introduce the first speaker. We have a short lecture, but short means that sure is concentrated and then is very, very interesting and motivating. Then this lecture is from Franz Kensbaum. Probably I pronounce very bad the name. Sorry, Franz. It is difficult to match consonant for me. Franz is a very interesting person from my point of view. He's working in the Vienna University, but he's a person that is very motivated in order to communicate science in the best way that you can use for this word, communicate. I think that your presentation about Caroline and William Herschel probably will be interesting for you, and I hope that open a new window to try to discover something more about infrared. Thank you, Franz. When you want, you can begin.
Oh, thanks a lot for the nice introduction, Rosa. And of course, also thank you for your fantastic work to motivate so many people to work on this very important topic. Let's try to start the presentation, the whole screen, I hope. Let's check. I'm going to remove this now. Do you see my screen now, Caroline and William?
I
You see
think
it
that
already?
no, not yet. We only now, yes.
Yes, now
Yes.
you see
Oh, yes.
Caroline and William. Yeah?
Wow, one
Yes,
more.
yes, yes,
No.
yes.
Okay, so
Yeah?
it's hard for me to check because I have to use two screens, so it's not clear.
Okay.
So thanks again for your nice introduction. I will report a little bit about our educational outreach project on the work of Caroline and William Herschel. Let's start with first recapitulation of the history of the background. In 1800, while studying the heat and color connection, William Herschel discovered the infrared radiation more or less by chance. It was at that time the first invisible radiation. It was not suddenly, it was not magic, but something you could physically test. Before, the only invisible thing that was had a physical relation was magnetism. That was also a physical, invisible force. But infrared radiation was the first radiation that could not seen by the eye, but had effect that were measurable. Other forms of invisible light followed later. 1 year later, the UV radiation was found by chemical experiments, and much later, radio waves and X-rays followed. Today, of course, you all know that infrared light is widely used for many applications, both science, technology, and so on. Coming to William and Caroline, they were not working alone. So they are very good examples also in our educational programs that working alone is not the norm in science, but working together is very important and leads to fantastic results. So they can work as an example, as an interesting case. Caroline, of course, started as assistant to her brother, but over the years she gained quite some independence, published her own papers on comets, stellar clusters, faint nebulae, double stars, many observational projects they carried out together. And in the end, as I said, she gained quite some independence of her father. So she is also a role model for female research, for this research that is carried out by females. And at that time, it was something very, very special. Starting in 1787, she started to get paid for her work by the ground. That was really exceptional. She was the first female astronomer being paid for research. And of course, she also received in the end several honors, high honors. In 1828, she received the gold medal by the Royal Astronomical Society, and she was honorary member starting in 1835. So many years after her brother died already. She carried on many work that was started by her brother. She was really an important figure. With this background, we started our outreach project. You have to know that my own research that I'm doing in my group is based on infrared radiation. And one of our very important tools studying infrared radiation from the stars was the Herschel Space Telescope. This was a space telescope launched in 2009 by the European Space Agency. And we thought that we will accompany our research that we do with this space telescope, where we also build some technology at our institute for it, namely the onboard computers that were controlling infrared observations. We thought that we do an outreach project in parallel based on the teamwork of the Herschel siblings and the pioneering role that Caroline Herschel plays for women in science. And our outreach was based from the very beginning on a combination of art and experiment. So not only doing the normal outreach with giving talks about why science is important and so on, we thought that we will use different means that include, as I said, art, includes small experiments that can be carried out in school. So it fits very well also the initiative of Caroline.
Es Cristina la que...
So one of our central elements in our outreach was that together with some artists, we wrote a theater play, that lasts about 35 minutes, 30 minutes, 35 minutes. And during the play, the siblings, Caroline and William Herschel, do their critical experiment on the detection of infrared radiation by the sun. And of course, it's funny, it's a funny play, you know, there are some problems they describe. They also speak about the past when they were doing music. You have to know Caroline was a famous singer. William was a conductor and composer of classical music. So they speak about their past, and by this you learn how science is carried out and how they came to this very important discovery of the infrared radiation. After our theater piece, and you see there in the background are hopefully the movie running, we give hands-on experiments with an infrared camera, and we provide, of course, the script of this theater piece, both in German and in English, so also to be used worldwide on our online sites. And now you will hear an interview with them. So this is very special done for this presentation. I hope you can hear it.
We all know Caroline and William Herschel from the scientific world. There are many discoveries in astronomy and physics. But today, you can meet them like you never met them before. Today, you have got the exclusive chance for the first personal TV interview ever. So, Caroline, happy birthday at first. Today is your 271st birthday. It's unbelievable. How did you experience the past 3 centuries?
Right. Thanks a lot for the congratulations. I have to say, it's really amazing how the world changed in the last centuries. I mean, all these new discoveries that were made after our first experience, our first studies with infrared radiation. I mean, you're even filming this now with an infrared camera. It's really amazing.
And your brother, William, I mean, you worked a lot with him. Where is he anyway?
That's a good question, right? I mean, he's probably late as always. I told him he should be here at 10, but he's not.
Sorry, Caroline. I was looking up, you know, this old prism that we were using in 1800 for our solar studies. Sorry.
But I told you that you should be here at 10.
William just said prism. I mean, today we use other kinds of modern technologies, new techniques. What are your feelings about them?
Right, so back then we had really very, very simple instruments, just very simple prisms, very simple thermometers, and today there is even a satellite that carries an infrared detector, a whole telescope in space. So this is really unbelievable, and also the science that can be done today, it's no comparison to back then.
What differences do you see to modern technologies, modern techniques and instruments?
with the Herschel Space Telescope, named after us, one can, for instance, even measure the composition of cosmic matter.
What about your birthday? What are your plans for tonight?
Right, we're actually going dancing to the Vienna Science Ball. Actually, William, you didn't dress up.
Sorry.
Now we're gonna come late.
Yeah, okay. Bye-bye, Stefan. Bye-bye.
Thank you very much.
Can you take the camera?
Sure, just take it, I guess. Well, it seems that Caroline and William have lots of fun dancing at the Vienna Science Ball. Obviously, they are used to long nighttime activities. Well, for today, I say goodnight to you. Thanks for watching us, and see you next time.
So I hope you have seen our short movie. It was, of course, a small joke. We cannot do real interviews with them, unfortunately. It would be quite interesting. But it was a motivation for you all to visit our webpage, whereby you can see all the elements that we do in our Herschel project, in our outreach project. You learn about the historical discovery. You can redo there the critical experiments, so there's some explanation to do them. You can listen and watch related podcasts and interviews. You can download our theater script. Yeah, maybe you can stage this half-hour piece yourself in your school with the children. You also can get experimental boxes. We have produced some small boxes with prisms, with thermometers, where you can redo the experiments in a relatively simple way. So go to this webpage, get the information there. You don't have to write down, I think, the link. If you Google Herschel and rainbow, you should find it, and maybe Vienna. Google will find it for you. So I hope you like our outreach project. You saw that we tried to do it in a slightly different way, to include art, to include the theater piece. Maybe you recognize that William Herschel looks like myself. I was playing it together with a PhD student of mine. So we had lots of fun visiting many places, giving our piece there and motivating the younger ones to be interested in science. Thanks a lot. Maria Rose, I don't hear you.
We don't hear you.
No? Maybe Maria Rose.
Thank you. Thank you.
Oh, you are still moving.
Thank you. No, I said that we have time for some questions that somebody have about after your wonderful presentations. I enjoy very much your images in infrared, that they are very spectacular always. I don't know if somebody have one
You have
question.
plenty of time. I see many children watching the presentation.
Yes,
Hello
many children.
to
They
Vilma.
are from Lithuania, they are a primary school.
Hello.
And we have here the group
Hello.
with
Can I
the children. Yes, Jivaji,
can
do
I
you
make
want to
can I
ask?
make a comment here?
Yes, please.
You know, especially in this time of COVID, I don't know whether people realize that everywhere throughout the world, people are using infrared. You know, I mean, I hope that people appreciate how
Yeah,
much
yeah, yeah.
infrared has helped us, you know, to
Exactly. On
Yeah.
airports everywhere, of course, infrared cameras are measuring
Yeah.
the temperature of our heads and
Exactly.
picking out persons that have fever. Yeah, so that's
Exactly.
quite important technologies. And
Yeah.
many of us have infrared ear thermometers. So this
did,
is
yeah.
really now enter daily life, or think about our TV remote controls.
I did.
We are using it.
I did my master's research during my master. I used a infrared thermometer called Staugessteig at that time for a European thermometer, and I
Great.
did research for using that. You know, since I have been exposed to that for a long time. Also, thank you.
Thank you for your comment. Maybe another comment, questions? Maybe the people is thinking, I have a question for you, friends, but I read that it is possible to use a camera, webcam, in order to modify a little bit and to have one infrared camera. Do you know something about this?
Yeah, in principle, but it's not a thermal infrared camera. You can measure then the infrared radiation, let's say up to 1 micrometer. That's possible, you know, with a CCT, with a silicon CCT, you can measure up to 1 micrometer. You cannot produce an infrared image as we used for our movie, because this is a 10 micrometer. That's a much longer wavelength. But you can do a little bit of infrared experiments. For instance, a TV remote, the light that is used of a TV remote, that you can image then with a webcam.
Okay.
So this is, for instance, possible, but you are not sensitive enough, for instance, to measure a temperature on your head.
No.
Because for this you have to measure at 8, 9, 10 micrometer.
No, only my suggestion was because it is not normal to have one camera, such an infrared camera in one school. And then for this very, how do you say, there are teachers that have a very many abilities for making by hands, something.
Yeah, hands-on experience.
Maybe it's possible to converse in some way.
Yeah, you have to remove from the webcam. You need a webcam, a relatively normal. They have an infrared blocking filter. They have built in a blocking filter that prevents infrared to be detected, because you want to have normal colors. But if you remove the filter that is in front of the chip, then it gets sensible up to 1 micrometer, as I said. And if you then put a filter on top of it that is rejecting the visible light, yeah. So let's enter light only after, say, 700 nanometers, then you really see this near infrared light. It's possible. It's not a big investment, so you can do it if you know how to modify this. This is possible. I'm sure you find online some resources with tips what is the best camera to buy, what is the best webcam. So it's not very expensive. And there's also, but from thermal cameras, there are now coming a few devices that you can directly attach to a mobile phone. So you can buy a thermal infrared camera that you connect via the USB to a mobile phone. It's a bit more expensive, but you really then see a thermal infrared image.
Okay, and the quality is better. Okay.
It's better. It's not as good as a dedicated camera that costs 4,000 euros, but it's for about 300 euros or so, which is a lot of money, but it's more accessible than 3,000 euros. You can get infrared images, real thermal infrared images with temperature readings now.
I hope that your suggestions give ideas to our teachers that they are listening this session. Thank you very much, Franz. And if we don't have any other questions,
Rosa.
Thanks a lot for your initiative.
Yes, we have one question common from Greece.
Yes, hello, Rosa. You can't see me, but you can see my students now. We would like really to thank you for this presentation. It was extraordinary. Okay, we will try to buy an expensive infrared camera, since we still now use, the web cameras by getting off the filter. But
Yeah,
it
yeah,
was
but that's possible.
exceptional. Yes, but it's not the quality you showed. It was exceptional and quite genius. All the play with the infrared camera. Thank you very much.
You're welcome. Good luck.
Thank you.
Well, then, thank you very much, Franz. And the next speaker is Vilma. Well, I cannot pronounce your name in a good way. Then I think it's better that I don't say it. Is from Ramigala Gymnasium in Lithuania. Ramigala is the name of the city. And we have here all the students of this course. I don't remember the number of the course, but Vilma will explain to us. Please give Vilma, it's your turn.
Okay, hello from Lithuania, from Ramigala. Ramigala is the small city, small town in the middle of the Lithuania. And there are students from our school, and they are first grade students. It's their first year at school. Say hello to everyone. Hello.
Wow.
The students that participated in this experience are 7 years old, and it is their first encounter with the science. I think they had a lot of fun and enjoyed participating in this global project. The kids are proud that they've got included in the list of schools that had a chance to repeat the Herschel experiment after 200 years. The experiment was a great success. And they used to try very simply experiment, I think. They used just sunlight, thermometers, and prisms. And the students were interested in how temperature changed and wondered why certain kind of rays were invisible to the human eye. And during the time they do this experiment, the students were motivated throughout and they enjoyed it a lot. And I think that's all. That's all from us.
Yes, maybe you believe that one of your students want to explain a little bit the feeling that she or he has. You can translate if necessary.
Maybe, let's try. Vaikai, gal galite pasakyti, kaip jūs jautėtės, kas jums buvo, ką jautėte eksperimento metu, kas patiko? Lietuviškai pasakyti. Lietuviškai.
Man tai patiko tas vaizdas spalvotas. Man irgi.
Okay. They enjoyed the colors. They enjoyed the colors that they've got from this experiment. They saw prism at the first time in this experiment. They used it at the first time. What else? They were afraid, they said. We were afraid of that experiment.
Well, probably it is a good idea to repeat, to play, especially with the prism, in order to see the colors, what is moving and all of this. This is very special for all of us and for children probably too. Well, thank you very much for your contribution. I am very happy that you stay here with us. And I want to say bye-bye to the students. And thank you very much. And thank you very much to begin to make experiments in science. This is a very important thing. Thank you. Bye. Well, thank you very much. And after this presentation, the next speaker is Sheila Rose from Philippines, and I saw that. Yes, Sheila, when do
Hello, Rosa.
you begins your presentation? Thank you.
Okay. Thank you, Rosa, for the opportunity to share the experience of doing the Herschel experiment. I am Sheila Rosia from the Philippines. It's good afternoon for my case. It's already around 4:30 in the afternoon, and it's about to rain. It's really dark outside, despite it being afternoon. It's really about to rain. So the experience that I had with this Herschel experiment, it was quite exciting. Unfortunately, I was not able to do it with students because the state of the COVID pandemic here with us, it's quite our cases are getting higher. So school has not yet opened. We are not allowed to go to school also. So I only had one chance to do the activity at the school. So it's just me and the experiment. I was quite fascinated with how I was able to do the activity with just a prism and some types of thermometers. I did it with two types of thermometers. One with a digital thermometer, the one that's like the sensor, and then the other one was the alcohol thermometer. It was fascinating and yet hard to place the thermometers at the right spots. If I may share some pictures, would that be all right, Rosa? So I had the different I tried it several times. I don't think I was able to do it correctly, despite doing it a lot of times. Sorry for that. So I did it. So here they are. I hope you are able to see my pictures. So I did it I think 4 times with different material, two types of thermometers. This was done during the afternoon, so I had a better result here. However, my pictures limited my results. It was hard for me to place the thermometer at the right spot for the infrared. Although it was very interesting that it really is not, even though I don't see the colors, I don't see the light hitting the thermometer at that point, it is still recording an increase in temperature. This is my second attempt with a different type of thermometer. I used digital. Still, the problem was my placing of the thermometer on the infrared part, just a little bit beyond the red. It's quite challenging for me to place it correctly because the sunlight at that time, uh, the trees are making the sunlight dance. So the prism is the colors produced by the prisms are also dancing, so it keeps on moving. That is why I had different trials, and then I did it in the afternoon. Same thing. It's a little bit less for the recording of the temperature, maybe because of the place where I did this was in the hallway. So this is me trying to do the experiment on my own at the hallway. So this was late afternoon. So it was really a very interesting experiment. I tried to replicate, or I tried to do it again. Unfortunately, the weather now in the Philippines is not cooperating. We've been experiencing typhoons for the past few weeks. Only a few days of sunlight, and so I was not able to do it again. I'm so sorry for that. But then again, I really enjoyed doing the experiment. I hope I can share the experiment and make my students do the same thing when we are able to come back to school. Thank you very much.
Thank you very much for your presentation, Sheila. And I hope that you can repeat, especially when you have a good sunny day, because I know that in your case, in some cases, it is very difficult. Probably it's the same situation that in India. The next speaker is Samir Sajdeva. And I know that they are now in raining period, but I know that the people that is very active also obtain the possibility that the sun appears. Okay. And, well, Samir.
Yeah. Hi all. Yeah. Thanks, Rosa. Yes, it is raining like cats and dogs in India. This season, I mean, in India this year, it was very unexpected. Still, it is raining since uh, July end or towards August starting, and we have hardly seen sunny days in all this time. So it was really very difficult to get a time slot, I would say. So we had to take an appointment from the sun to appear and allow us to do the experiment. So I would just show what we have done. And what I in person did is that we had a live Zoom session with the kids, because right now there are some challenges with schools, and some are open, some are not open, depending on how the COVID cases are there. So, okay, let me share my screen. Is my screen visible?
Yes, it's
Okay,
coming.
yeah.
It's
So,
coming.
yeah.
Now, no.
So,
Ah, yes, 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 yes.
okay. So, Rosa told me about this Herschel's experiment, which was really very interesting, and I found it that we can do two experiments in this one. So, one is about the infrared, and the other one was showing to the kids how the sunlight is divided into different spectrum of lights also. And there was something invisible which Herschel actually discovered at that time. Uh, so our experiment readings, we could not take just like Philippines, we could not take much readings, or even though I had lab thermometer plus infrared thermometer also, but still I hardly got a window of half an hour or so. After that, again it was cloudy. So one reading, first reading was taken from the South India location, Kerala location, by Naveen, my colleague. Then the other one was taken by me from Delhi location, North India. So basically, what I did is we turned on our camera. We asked kids, those who were attending online sessions, they were at home right now, so they could attend, and we could explain them how this experiment is being done. Next year, we are planning that we will provide these thermometer and prism along with the document or something like that, with video to them, to each one of them, so that they can do the experiments, because everyone is based out of different locations. So it will be really interesting to see what readings they are getting from different locations. So the experiment had a lot of challenges, as I told. So weather conditions this time was unexpected. It is still unexpected. Now in South India we have chances of cyclone also. So most of our team members and students live in a place where it is raining most of the time or cloudy. So we were in mixed mode. Some students at this time are in school, so they cannot attend anything, and some of them are attending via online classes. So again, due to COVID and courier issues, so we could not send them each and everything. So this was the first reading from Naveen. So as whatever format has been given by NASE, so we performed this activity, and then we had different spectrums. So the last thermometer, the third one, we kept it slightly off from the red radiation rays, and then we measured the temperatures after given seconds. Then this one was done by me, and I turned on the zoom and everything. So this was the reading which was taken, even though it was still kind of cloudy, but still I managed for half an hour uh, standing over there and got the readings. So yeah, so we had a Zoom session wherein we explained to the kids. They were of different ages, from small kids to college students also were there. So we explained them how spectrum works, how the sunlight is distributed into different spectrums, and what is infrared, and how this Herschel's experiment uh, brought a revolution in the world. So as you guys have already mentioned about the thermometer and so many instruments are there, including satellites and space missions. So yeah, that's it from my side.
Thank you very much, Samir. Thank you for your presentation and thank you for your effort that I know that is not the best situation now. This year is so difficult with the COVID also in many,
Yes,
many countries. But we have to continue trying to work and repeating experiments because this is the best motivation for continuous in the school. Thank you very
yes.
much. Thank you.
Thanks, Rosa. Thanks all.
The next speaker is Ishan Muharik from Indonesia, from Bogor.
Okay. Yeah. Thank you, Mr. Rosa, for the time. I'm very happy can join this meeting with all friends of NASA. Maybe I'm just little sharing about Herschel experiment that we do in Bogor, Indonesia. Yeah, first, maybe I am and my student are very happy because we can do this experiment and especially with my student, maybe that's first time to do experiment like this. Maybe they never to doing this experiment. Okay. Okay. My favorite experiment. I try many times because yeah, like the other country, because the weather is not good, rain, and now in here is rain. Yeah. Uh, yeah. But honestly, we make data about the temperature of thermometer. Maybe in the experiment, we what I some difficult for this setting the rainbow of frames of glass. Yeah, yeah, this frames. Yeah, the sunglass. I setting the shadow. Some I not to the shadow light or dark or large or small. It's difficult to control because I maybe hurt in my hand. Yes. And then yeah, the result of experiment, we know that the thermometer in the red shadows is higher before than the shadow, and the third is yellow, and the cooler flowers is in the blue area. Maybe it's same with the others. Yeah. Okay, maybe that's just that what I share to you all. Thank you for Miss Rosa. I'm sorry, is my English not good?
Don't worry, my English is not good also. Doesn't matter. All of us, we don't speak English very well, but I am sure that you speak very well Indonesian. This is not a problem.
Thank you, sir.
Thank you very much for your contribution. And I would like to summarize the feeling of your students after the session was positive or they are negative? They enjoy or they are boring?
My student is very positive thinking and they enjoy the experiment, but just 3 students they do experiment. The other student are jealous with that 3 students do the apa experiment. The other student will do the same like that.
Excellent.
Okay.
But this is the most important, really.
Yes.
Thank you very much for your contribution. And I would like to invite the next one speaker. The next one speaker is from, sorry, one moment, is from Greece, is Margarita Metaxa that I saw here. And also we have another teacher from Greece, is Dina, but I don't remember the family name. But in any case, welcome. And Margarita, I don't know, Dina Kraisan, yes. Hello.
Hi, Rosa. How are you?
I don't know if the main speaker will be Margarita.
No, the main speaker will be my student. So
excellent,
we
bravo.
can start. Okay, we really enjoyed.
Bravo.
Good morning. My name is Evelina Gonzalez, and me and my classmates conducted the experiments. Now I will introduce them to you. They are Martina Gaga, Manolios Garcia, Spiros Vasilopoulos, Thaimus Athanasiou, Aphrodite Griva, and John Theodorou. So Spiros will now talk to you about the experiment.
All right. So hello. At first, we had very little knowledge concerning the infrared region of the spectrum. We were aware of the existence of thermal cameras, but we didn't know how they work. Therefore, before we conducted the experiment, we knew practically nothing.
So the process of the experiment was quite simple. At first, we used a glass prism, 4 thermometers, a cardboard box, and a white sheet in order to conduct the experiment. After that, we placed each thermometer on each color and one extra next to the red color and measured their temperatures per minute. We realized that the temperature on the color red was higher than the other colors, but also the temperature next to the color red was higher than the ambient one. So we came to the conclusion that there was an invisible part of the electromagnetic spectrum called infrared light.
So before conducting the experiment, we read about the infrared region of the electromagnetic spectrum. And we found really fascinating the fact that we were about to repeat the exact experiment that William Herschel conducted, which resulted in the discovery of the infrared. So what we learned after the experiment was that what the discoverer at first called heat rays are actually the infrared rays, which are similar to the ones we see reflected through the prism, except they are not visible to the naked eye.
Okay, overall it was a great and fun experience. At first we had some difficulties conducting the experiment, such as placing the prism, but we soon overcame those and we learned a lot about our favorite subject, which is physics, in an entertaining way.
So that is from us. Maybe Konstantina would like to tell something from her point of view.
I have a lot of students participated in Herschel experiment for the first time. It was junior high school, and they were make fun of it. They loved it and started asking, "Madam, how can we do another experiment like this?" So next year will be more specific and a lot of experiments. Nothing from me. Nice to see you all.
Thank you very much. And we are thinking in the next experiment for next year, but this is a secret. I cannot say more. I cannot explain the guys. Thank you very much. Well, thank you, Grace. Thank you, Margarita. Thank you, Dina. And the next group of, I said group because I believe that there are more than one speaker, is from Iran, from Bushehr. And there is a group of students that work with ITAO, that it is a group of teachers in Iran, very, very active. I think the speaker is Ramin. Okay. Thank you.
Hi, I'm Shahzad. Unfortunately, our friend Hasti Hedayat, who wants to present and confront this thing, her town has no service, has no internet service right now, and we have problem. We can't come, and if you can we confront at the end of this meeting or not?
I would like to know how many students work in this experiment, how many students prepare and after observe the result.
We are 4, and our main student who wants to conference is not here, because of the poor connection. So we want to be patient. Maybe she can come at the end of this week.
My question is how many students?
4.
The number. Okay.
4.
Excellent. Oh, sorry. And then it is a wonderful opportunity to repeat the experiment with more students in the next weeks in the future. And I hope that you send to us a report of your activities, because I know that you are very active, and I would like to explain to the other countries that the teachers of this country, the teachers that work in this experiment in this country, they are in this moment in a plane, because they are going to Spain for the last event that we have on Friday morning in Granada, in Spain, in Atarfe. And they are in this moment in the plane. And then it looks that they prepare that one student to teach or to explain to us what they are doing, and they have a problem of connection. Okay. Thank you very much, Ramin, for your contribution. And I am sure that you continue working in astronomy, because the team that you have really is very, very active. I know that. Thank you. Thank you very much. The next speaker is from Tanzania, is Jivaji, who was here. I saw you. Yes, Jivaji, when you want to present your contribution.
Yeah, let me share my screen.
Yeah.
Oh wait, I don't know. Wait. Let me. I need to. Where do I share my screen now? Yeah. Okay. Go to that. I'll just share my screen just a few minute or two in a minute.
Okay, don't worry.
I'll share.
We know that technology help us.
Okay, can you see can you see my screen?
Not yet.
To avoid murdering, don't share entire
Yes.
screen.
Now, yes. Sorry. Yes.
Okay, you can see it.
Yeah.
Okay, so I was trying to get it full screen, but that doesn't come. But you can see a little bit of the setup and some data. This I had announced it in our astronomy group, teachers group, NASA group, because we have done the training here physically with Rosa and online also. So we are still continuing with our NASA training. So we have a lot of teachers who are involved. So I announced it, and several teachers were trying to attempt it, but eventually my colleague, Mr. Fadili, a teacher from Gogoni Secondary School, was able to do it. You can see the setup here where he has used a bucket to get a shade, and the prism. This was a little bit of high, around 11 o'clock, the sun. So he was able to get the screen, the spectrum on a styrofoam. So he has used digital camera and glass, alkaline glass thermometer. So I will ask maybe Fadili, if his already microphone is on, he can say a little bit about how he went about his experiences. Fadili, can you speak for a few minutes? Hello?
Yes.
Yeah, I had asked him to be online.
Yeah.
Okay, so if he can hear, he can say a few words also. But otherwise, Fadili,
please, is your turn.
I think he may not be. I told him to keep his microphone on, but then again the technology and all that will. Okay, so let me just continue. We tried this for several times, and even the other teachers also tried it, and we had, there's an unseasonal rainfall here. So for the past, first of all, there was some holidays, so he was not able to be around with the equipment and all that. And then over the last week or so, we had a lot of rain, and suddenly yesterday, Sunday, everything worked out. And he was able to get some good data, which we are now able to show that when he placed the thermometer, this is a styrofoam sheet on the floor here. You can see that there is a thermometer that's just outside the spectrum, and then one thermometer is inside the spectrum, and then one thermometer is outside again on beyond the red side. So, and then he compared also with the digital to make sure that he has some corroboration, some support from another instrument also. So after 5 minutes, we saw that the temperature had increased, and then it increased again to 30 point, by a tenth of a degree until it stabilized at 31. So there was a 1 degree difference he saw between the other thermometers and the infrared thermometer. So it was quite an experience just to get the setup right and to get the sun right also. Thank you very much.
Thank you. I would like to know, in your country, in Tanzania, it is it is easy to find a prince and in one school, or it is difficult? And what about the thermometers? Also, it is difficult to find them?
No, most of the schools will have a prism and thermometers. Okay. At least a few. Most of the school will have. That is, optics is an area where it's much easier to get equipment, and thermometers are also. Most schools will have thermometers. This is especially alkaline glass thermometer. Yes.
Wonderful. No, it doesn't matter. The kind of thermometer, it's enough that can use. Okay, thank you very much, Ivaji.
Thank you. Thank you very much.
I would like to offer the opportunity to the next speaker, to Ivo Jokin from Bulgaria. Ivo, he was here and now. Okay. Hello, Ivo.
Yeah. Hello, Rosa. Hello, dear colleague. Thank you very much for invitation for this unique project. So I will share my screen.
Yes, we can see your
Can you
screen.
see?
Yeah,
Yeah.
yeah, no problem. Yeah.
So, my name Ivo Jokin. I am a director of Municipal Center for Extracurricular Activities and STEAM teachers. In this center, situated in Riverside, beautiful Riverside, Danube, I am a national coordinator of International Day of Light of Bulgaria and a Dark Sky Ambassador for Bulgaria. And for this instant, this is for very important for me, for students and teachers from Bulgaria, to present, to conducting this Herschel experiment, because in Bulgarian schools, we have not time to, and we don't conducting this experiments. So this is maybe how to say this first time to organizing in Bulgarian school. For preparing, I choose one high school from Pleven city with more than 500 students. There is specialization.
Ivo, we have problems of sound. Maybe could you remove one of the two cameras that are you using? It is possible that you remove your image and we only see the PowerPoint and your voice. Ivo? I'm really sorry, but we cannot listen you. We cannot hear you. Okay. Then I have the PowerPoint of Ivo, and then maybe I can share with you at least the PowerPoint, and because maybe it's better that you can observe also here. I have here. I will try to share with you his PowerPoint. No, what is this? I cannot share with you. Cristina, could you...
Dime.
Sí, mira a veure si puc compartir la imatge perquè jo tinc el PowerPoint d'ell.
Però això ho has de fer tu des del teu ordinador.
But I cannot do it. I don't know what is the problem, but well, I will try now. Now it is possible that you can see the PowerPoint now. Did you see the PowerPoint of Ivo?
No, Rosa.
No?
Not yet, not yet.
Yet.
Experiment, yeah, with thermometers.
Oh, okay, better. Okay, we cannot listen you and see the PowerPoint. I suggest that you only explain the experiment, and this is enough, okay?
Okay, I will stop share screen.
Yes, and only listen your voice, because it is not possible. The quality
Now
of the internet,
it's clear?
yes, now yes.
Yeah, you only see presentation with
We lost your voice again. Only
Yeah.
your voice, and only explain to us the activity, no more.
Yeah. The experiment conducting with three schools, different schools, one from Pleven, high school, biggest school in Pleven, specialized in science, biology, chemistry, astronomy, physics. Secondary, the second school was from rural area, very small village in Krušovene village in our municipality. And third school was in exactly in my municipal center with students one day science camp. Very happy, they was very happy because in Bulgarian schools we're not conducting Herschel experiments. So again, thank you very much for this invitation. And thank you very much.
Thank you, Ivo, for your presentation. I know that you have difficulties because you are traveling, but well, it doesn't matter. We understand that technology in some cases.
Yeah, here is in the hostel is Wi-Fi is not good.
Okay, don't worry. Thank you very much. The next speaker is Maria Peto. Maria is from Romania.
Hi, I am here. Do you hear me?
Yes, very well.
Okay, okay. I will present my school activity. Can I share my screen?
Yes, please.
Please. Do you see my screen or not?
I don't see. One moment.
Okay, let's try again.
Now, yes.
Yes.
Yes, Maria.
It's okay?
Yes, excellent.
My school is Chemical High School from Romania. We are our secondary high school, but we have also primary and secondary 11 students.
Sorry, Maria, before we only see one screen. Now we see all your slides.
Okay, let's.
Now better, yes, now better.
Oh, let's try again.
We're lost.
Now?
No, you have the Google Meet screen.
Oh.
Choose another screen, I think.
Okay. I choose then this one, but do you see my screen?
Yes, now we can see.
Okay.
Yes, now excellent, no problems.
Okay. It's okay now?
Okay.
Do you see?
Yeah.
We started the experiment with 6th grade students. They start to study the physics in September. It was only a demonstrating experiment, but the weather is very cloudy. We can do the experiment, but not with concluding results. We repeat the experiment 2 days later with 7th grade and 8th grade students. Here are our results. They are slightly good. The students was amazed with the experiments. Could demonstrate that the colors and the temperature are different. The blue is low and the red one is high. But we have some difficulties during the experiment. The first one to fix the prism in some way. We can put the spectrum on the right thermometer. The spectrum was not wide enough or not sharp enough for measurement the first time. After we have difficulties because it was very windy and the spectrum moved from the thermometers.
Mira, estoy online en una conexión. ¿Te puedo llamar más tarde?
Okay. The other problem with the slightly movement, the fine movements of the prism displaced our spectrum. But finally, the students was very, very pleased and they liked this experiment.
Thank you very much. Thank you very much, Maria. I think that the best important thing is that the experiment will be attractive, interesting for students, and probably motivating that they continues interested and they want to learn more and more. This is the much more important.
Yes. We will repeat in spring this experiment with more classes.
Excellent. Bravo, because it is very simple and very, very beautiful. Thank you very much, Maria.
Thank you.
The next speaker is from Tunisia. And well, I see, Sarah here. I see you. Sarah, well,
Hi.
Snowy, or I don't know how to pronounce your name. Sorry. Hello.
Hello, good morning.
Good morning.
I want to thank you for the invitation, and it was a pleasure to work and collaborate with you. First of all, we made a wooden box. I used a big prism. This prism was placed on top of the box. Our remarks, it's the position of the box changes with the season. In September, we must tilt the box so that a broad spectrum is formed on the bottom of the box. So it all depends on the height of the sun. Okay?
Okay. This is true.
The difficulties, weather situation. We programmed this experience several times, but bad luck, we have overcast and cloudy sky. So we can't take measures, which forces us to report the experience. Also, when the variable sky alternating and cloudy periods and sunny periods, we can do this experience. Okay?
Okay.
About the thermometers placed in the shadow, we have to wait for the temperature to stabilize. Yeah. Sometimes we start the experience again since the results are false. The thermometer placed in the shadow indicates on very high temperature due to the heat outside. So we can do this experience. Donc, about the students, there are two types of students. Informed students who have already studied the composition of sunlight. They were curious to know how to highlight a light invisible to the eye. So they're very impressed with the results. However, the standard non-affirmed, we have explained the experience, and they do the experience, and also they are impressed with these results.
Thank you. Thank you, Sarah. I am interested in your point of view because remember, all of you, that this project begins in the equinox of spring and finishes in the equinox of autumn.
Yes.
And this was the reason that we give so big period of time, because also it is important your latitude and your longitude for all of this. And remember that one of the information that we ask was the country, the name of the school, of course, and the latitude and the longitude, because all of this was important in the work of the activities. And our idea was that you try to do the activity in different periods of these 6 months in order to compare the results, because the results between today and tomorrow probably are not so different. Okay. Well,
Can I say one word here, please?
Yes, Jivaji. Yes,
You
please.
know, when we talk about the equinoxes, I think we use the word autumn and spring. It is the sort of a standard way of talking, but actually I think we should be using March and September equinox, because we don't have autumn and spring, you know, so it confuses people a lot. And these things, the months are more quicker to appreciate. Thank you. Sorry.
Yes. No, I agree with you, Jivaji. But I have the idea that I mentioned the names that I don't said who is who, because in the south hemisphere is not the same that in the north hemisphere. Okay.
No, but for equinox, it will be March and September anyway. So it is always the same. Yeah.
This is the same. Yes, yes. I agree with you. We have to invest efforts to try to change the mentality, because it is not easy. Okay. Thank you, both of you. Thank you, Sarah. Sarah is member of, is the staff of the La Cité de la Science in Tunisia, in Tunis. And it is a very important center, science center, science museum that cooperate with NASA from the beginning, many years ago. And we are very interested to continue with this cooperation. Thank you very much, Sarah.
Thank you.
The next speaker is Margarida Maria Correira, and from Portugal, from Porto. I saw before Margarida here. Hello.
Okay. Good morning, everybody. I am teacher in a small and quiet place called Junqueira in north of Portugal. This was a very interesting activity which enabled the link between music and science. During the experience, we had the privilege to listen in Garcia to Herschel's music, to show our students both sides of his life. In preparing the experience, we had some difficulties related to the timing of the activity, but also to the preparation of materials. Prisms are not a very common material in Portuguese schools. This limited the possibility of simultaneously carrying out the activity with several groups. We solved the problem by borrowing 2 more prisms from the local science center. We also had some difficulties in correctly positioning the prisms in the box in order to get larger spectrum. The biggest surprise on the day of the activity was having managed to obtain a large spectrum projected on the school wall. As it is usual in the history of science, chance has also generated new opportunities for us. The recording of temperatures was easier. However, the results we obtained were not always satisfactory due to the difficulties in reading the thermometer scale. On the other hand, the complexity for the age group for our students of physics associated with the experience led us to obtain the temperature in the shadow, in the UV zone, and not in the IV zone, for example. However, the complexity ended up facilitating further discussions. How is it possible for a radiation with longer wavelength and therefore less energetic to be the one of the greatest variation in temperature? How it is possible in the shade behind the red for the temperature to be higher? Those experiments ended up leading the students to discover infrared themselves and recapitulated what they knew about the sun electromagnetic spectrum. Without a doubt, this was a different experience for our students that will accompany them throughout the year. We are planning to deepen the connection between art, music, and science, two domains that are as important as complementary in our lives. The fact that we were outdoor with our beautiful sun, with accompanied us on this memorable day, made us for a moment forget this terrible pandemic. I would like to thank you, those responsible for implementing this fantastic event. It was very gratifying to be here with you all. Thank you very much.
Thank you very much, Margarita. Thank you very much to the Planetarium of Porto, because organizing many observations in many different schools. And this is very important for us because we arrive to more and more teachers and students. Thank you very much. Well, the next speaker is a special speaker for us, because we have here a short lecture also from the Observatorio Astronómico Nacional in Madrid, in Spain. And the speaker is Miguel Querejeta. He will explain us some details about the Herschel telescopes that they have in the observatory. Then I have here, okay, Miguel, when you want, and Marina. Well, Marina is the speaker of the last lecture, but I think that they decide to work together in both cases. Then you decide. It is good.
Exactly. We're going to share it. Can you hear us well?
Yes, please.
Excellent. Good morning, good afternoon, good evening, everybody. My name is Miguel Querejeta, and she is Marina Rodriguez. And we're talking to you from the Spanish National Astronomical Observatory in Madrid, Spain. In fact, you can see some of the beautiful buildings that we have in the observatory behind us, and you can even see a dome over there. The reason why we're connecting with you today is because we know that as part of this wonderful program, you have been working on the experiment that led William Herschel to discover infrared radiation, infrared light. And also connected with light was the main occupation of William and his sister Caroline Herschel. They were astronomers, and they were able to make a number of astronomical breakthroughs thanks to the development of new telescopes. In this little talk, Paulino and myself, we are going to tell you about one very special telescope that William Herschel built for us, for Madrid. And it was arguably the very best telescope that he ever built.
But before showing you the telescope, we want to remember one thing. There is a strong relation between science and technology. Science requires the improvement of technology to be able to make new discoveries.
Sorry, Marina, we don't listen you very well.
Okay,
if you speak close to the...
Can you hear me?
A ver, ahora, repite.
Okay, yeah, because we have not a very good acoustic
Yeah,
here.
yeah.
Okay, you can hear me now?
Better.
Okay.
Yeah.
I was saying that there is a strong relation between science and technology. Science requires the improvement of technology to be able to make new discoveries. And on the other hand, the improvements of technology are made in many cases because of the requirements of science, the needs of science. You can have some example. For example, science needs better computers, better machines, better laboratories. And thanks to that, technology has developed, for example, better cameras or the internet, for example. Another very good example of that are the telescopes. Before the telescope was invented, the astronomy was done only by naked eye. I mean, the astronomer could only observe those objects in the sky that were visible by naked eye, and everything else, everything fainter than that, was totally invisible and unknown for them. But telescope was invented at the beginning of the 17th century in the Netherlands, and after that, the astronomers, such as Galileo Galilei or Christian Huygens, were able to discover amazing things. For example, the satellites orbiting Jupiter or the rings of Saturn.
Exactly. And sometime after that, in England, William and Caroline Herschel were developing new telescopes and they were making astronomical observations. And at around the same time, at the end of the 18th century, here in Madrid, a new observatory had just been founded. The astronomers wanted to have the best possible telescopes, and with the support of the king, who was very generous, Charles IV, they were able to buy a really, really good telescope from William Herschel. William Herschel, who was living in England, as we just said, took this very seriously. He spent a long time working on this telescope, and after some testing, eventually, the telescope had to be dismantled into little pieces and put into boxes so that they could be sent over to Spain. They were sent in a total of 52 boxes by ship to the harbor of Bilbao in the north of Spain, and then over the land all the way down to Madrid. When the parcels arrived here, it was quite a challenge to rebuild the telescope. But luckily, the boxes also came with some instructions. There were visual instructions, drawings that told the astronomers how to rebuild the telescope out of the small pieces. This is a bit like when you get a parcel from IKEA and you want to build this piece of furniture. There's lots of pieces, you don't know how to assemble them together, but there are some drawings that guide you in this process. In fact, you can see some of these drawings behind us. Come with us. These are some of the original drawings that were sent over with the boxes and that allowed to build the telescope. You can see every single detail is explained here with great accuracy. So it took some time to rebuild the telescope, but by the year 1804, the telescope was ready. It was operative and it could carry out the first observations.
But unfortunately, the telescope couldn't be used for long because only 4 years later, in 1808, we had a war. France, under the rule of Napoleon Bonaparte, invaded Spain. And when the French army arrived in Madrid, the French army decided to take the hill on which the observatory is built, because it was a very strategic and important place in the conquest of the city. They took the hill and the observatory and they completely destroyed the telescope because they wanted to use the wood of the structure of the telescope to make fire, because they were in the middle of the wood. But the astronomers that were working here in the observatory before that knew that this could happen. They could see that as a possibility. So before that happened, they took everything they could, meaning the documents with all the design and the instructions to build the telescope and some of the main pieces, mainly the mirrors of the telescope, and they took them to the house of one of the astronomers. And after that, they managed to keep those pieces and documents hidden in one of the towers of the main building of the observatory. So they saved them from the destruction of the war. So after that, the observatory was able to keep those pieces and documents for more than 200 years until at the end of the 20th century, about 25 years ago, it was decided to rebuild the telescope using the same documents and design and instruction that were used 200 years before and the same pieces that were conserved. And this is the result that we have. You can see it is the exact replica of one of the biggest and best telescopes built by William and Caroline Herschel at the end of the 18th century, built with the same instruction and design that the original one, in the same place, in the same observatory, and using some of the original pieces. And with it, we can explain you how it was used, how this kind of telescope worked, and how the astronomer managed to do some observations with them.
When most of us think of a telescope, what we have in mind is something like this, a long tube with two lenses at both ends. This is what we call a refracting telescope. We call it refracting because the lenses change the direction of the rays of light. Specifically, the first lens, which we call the objective, makes the light concentrate in this point, which is the focus, and then the second lens, the eyepiece, allows us to form an image right in front of our eyes. This kind of telescopes have a problem, though. Actually, two. The first of them is that they suffer from chromatic aberration. So, because the refraction index of the lens depends on the wavelength, the different colors of light will not concentrate on exactly the same point, and this will lead to distortions in the final image. Additionally, if we want to build really large telescopes, the lenses have to be very massive, and they are very expensive to build, and they can also make it hard for the telescope to keep stiff and to point robustly in a given direction, so the weight of the lens. So for this reason, a very intelligent person, who was Sir Isaac Newton, came up with a solution that solved these two problems at once. The solution is to use mirrors. In a reflecting telescope, like the Newtonian telescope, the rays of light travel all the way down to the bottom of the tube where they encounter a concave mirror. This mirror makes the rays of light converge in the focus, and with a secondary flat mirror, they are directed towards one side of the telescope, where we put the eyepiece and where the astronomer would look through. This is therefore an improvement with respect to the previous design, and actually most modern telescopes are built this way, and this was also the technique that Herschel used to build these telescopes. They are all reflecting telescopes. In particular, in the one that you can see behind us, in this huge telescope built from Madrid, the light will enter the top of the tube, go all the way down to the bottom. There it will encounter a concave mirror that will reflect the light back towards the back, towards the top of the tube, and that's exactly where the astronomer would look. Herschel had a very smart idea, and it was that he could get rid of the secondary small mirror by tilting the mirror at the bottom a little bit, so that the rays of light will not converge at the center of the tube, but at one end, one side. And because the aperture of this tube is large enough, the astronomer can actually look that way. So the astronomer would have to climb up all of this structure, and sit at that platform. And it's a very particular situation because the astronomer is actually facing exactly the opposite direction to that in which the observations are carried out. So the astronomer's back is facing the stars.
About the telescope, this is a very big telescope, as you can see. The focal length of the tube is 25 feet, meaning 7.6 meters, one of the biggest at this time. The total structure has a height of around 10 meters, taking into account the whole structure of the telescope, and the aperture of the tube is around 2 feet wide, meaning around 60 centimeters. And it was a very, very, very expensive telescope to build at this time. The equivalent cost today of this, if you want to have this today, you will have to pay more than 1 million euros to have that in your observatory. Regarding the movement of the telescope, it was a very challenging topic. It was quite difficult. And you can come with me. If you want to point the telescope to a certain direction, you have to move the tube both horizontally and vertically until you point to the right direction that you want. So, in order to move the telescope horizontally, you have to move the whole structure of the telescope by brute force. I mean, you need a lot of people pushing the telescope like here until you manage to turn it. So you need several people to do that. And to move the telescope vertically, you use, I don't know if you can see that. This kind of zip-like mechanism to move if you move it one direction or the other, you manage to put the tube of the telescope up or down. It is, as I say, very challenging because anytime that you move the tube of the telescope, you also have to adjust the position of the platform where the astronomer is observing. So you have to do a lot of things. And it's important to remember that the Earth rotates, meaning that when you look at the sky at night, the stars are moving all the time. So you have to observe one star, you have to be all the time moving and adjusting the position of the telescope. So you needed several people and a lot of work to do this, but they did it and they managed to do incredible things. And apart from that, it's also interesting to say that the reconstruction of the telescope was also quite challenging because this is a weird structure and it wasn't easy to find a company that accepted to build this. Many of them refused the project until one of them in the north of Spain accepted to build it. It was a company that is focused on the construction of boats, wooden boats. So instead of building a wooden boat, they built a wooden telescope. These quite a different things, but the pieces are not so different. So this is incredible.
So it was a pleasure to be with you today and to tell you a little bit about the telescope that William Herschel constructed for us for the observatory in Madrid more than 200 years ago. We will reconnect with you a bit later and tell you about some of the discoveries that William and Caroline Herschel carried out. But actually, as a final reminder, this telescope is much more impressive live than it can be through a video. And luckily, we're open to visitors. So if you ever drop by Madrid, do not hesitate to come to the observatory. Thank you.
Thank you very much to both of you. I would like to offer the opportunity to the participants for a question, maybe a comment. I don't know.
Maybe if I can say a comment here.
Yeah.
It is quite amazing. This is a really eye-opening presentation for me to see how Herschel was working and how difficult the observations are, and yet they make such immense contributions. So this is really an example I think we should be showing to throughout the world about how much effort, these days there will be more technological and, knowledge and all that new different types of efforts. But without these efforts, I think we will all be seriously left behind. So I appreciate very much the presentation made here today to show us this. I hope that this is available in a video also for me to share, for us to share with others also. Thank you very much.
Thank you. Thank you, Shivaji.
Hello. Hello, Rosa.
Yeah, Paula?
Yes, I want to congratulate the team. My students are very happy, very honored to see in live, online, even online, the telescope made of Herschel, and we are so glad to see it now made of you by his writings.
Thank you.
Thank you. Thank you so much.
Thank you, Paula. Do you want to add something more or to
Yes.
introduce more information?
Yes, Rosa.
Yes,
If I may, we have to do this as an educational resource for our schools. This video must be recorded, and we can use it on our schools. Thank you so much.
Then I would like to ask a question, but this is a question of, I don't know, a special question, maybe. Normally in one reflector telescope, the observer is looking in the middle of the tube, more or less, okay? That in this case, you have a wonderful escalier for observing on the top, on the end of this. Could you explain us what is the reason of this? Because this is not so normal from my point of view.
Totally. This is not standard at all. This is a novelty that William Herschel introduced. In fact, this kind of telescope is called Herschelian telescope after him. And the reason is that he realized that with the secondary mirror that usually one has in a Newtonian telescope, in order to redirect the light towards one side, one would lose about 30 or 40% of the light, which is a lot.
Yeah.
The reflecting materials at the time were not that good. And because this telescope is large enough, he had this very bright idea that by tilting the angle of the mirror at the bottom, by inclining it a little bit, he could make the rays of light converge at one side of the opening of the tube, at one edge of the aperture. And like this, he could put the eyepiece directly there and avoid losing this precious amount of light.
But then it's probably difficult to look from this point because you have the big tube, and
yes.
How do you decide where you put your
Exactly, it's not easy. So first one needs to use the little telescope that is attached to the tube to find the area that one wants to point to, and then once you are pointing in the right direction, then you have to very quickly climb up all the way to the top in order to make the actual observation. But the advantage of doing this is that you do not use that much light. So that's why we did it.
We have to be aware that today we are lucky that we can work with computers in one room with that. At that time, it was very difficult. To move the telescope, you have to run to do the observation and then start again. So it was complicated.
Amazing, it's just amazing.
It's wonderful, impressive, really. It's very impressive. Thank you. I don't know if we have some questions more comments, no comments? Okay, then thank you very much. We enjoy a lot our opportunity to see the telescope of Herschel. And congratulations, because you have the honor to be close to this instrument and enjoy it. And see you again in the last part of this meeting, okay? Thank you very much, Marina. And I would like to say, please try to talk close to the computer, because the sound is not very good. Okay, thank you very much.
Later. Okay,
No, for the next connection. I told for the next connection. Okay, this one speaker is from Germany. Probably I pronounce very bad the name, but it's Beate Brodeser or something like this here. Hello. Could you say your name correctly?
I will do it, yes. Hello from Germany. My name in German is called Beate Brotesser. I know it's difficult for you to say. No problem. It's a hard German word.
Thank you.
Yes, hello Rosa, and hello to the whole community all over the world. It's really impressive to see you all and be a part of the community. It's a really nice event. Thank you very much. Well, I have to say I'm new at the community, so I can't give you my own experience, but a colleague did the Herschel experiment, and I can tell you the results what my colleague did in Germany. The experience, the Herschel experience was made in 7th of September in Germany. We are in September between summer and autumn, and we had some sunny days, so the experiment could be made. And the measurement of the temperature is between 23 and 18 degrees Celsius. I have to apologize, and I'm sorry that I can't tell you about the students that did the experience, because I was not there. I just can tell you the datas. I myself, I am not at the moment at the school, so I can't do this, but I hope to return to school next and will do this activity with my own students in the future. I'm sorry, I'm not able to tell you more, but yeah, that's from Germany.
Okay, thank you very much, Beate. I am hope that you enjoy with your students when you come back to the school. And it is a very beautiful opportunity that they discover that there are some parts of the physics of the life that they cannot see but really exist. But this, I think, in any case, this is positive. Okay.
Yes,
then,
and
thank you very much.
Yes, I'm sure my student will enjoy the experiments.
I'm sure.
Thank you very much.
Normally, students enjoy the teachers that arrive to the classroom with a box and begin to put on the table different things. This is enough to catch all the attention, and they are very motivated to know what do you want to do. And this is always important, really. Thank you very much. Well, the next speaker is from Andorra. Is Carlos Moreno from Agora International School of Andorra, and probably also the students have an important presentation here. Because Carlos, do you want to talk, or your students?
Just to thank you the opportunity that you gave us to collaborate, to share with all over the world, with the students, teachers, colleagues, and I leave you with my students because I think they have enjoyed, and I hope they can show you. I leave you with them. Thank you.
Thank you, Carlos. Well.
All right, good morning. I'm going to project the PowerPoint. Just give me a second. Okay.
Es solo esto, José.
Arreglarlo. Can you see my screen?
¿Y por qué nos interesa?
Porque si no me interesaba,
Sorry, Aldo,
yo le diría, mira, lo siento, porque si fuera una que nos hemos equivocado.
sorry. Yes, please. Thank you. Okay, continues, Alberto. No. Well, I don't know tonight. What is your name?
Alberto.
Molt bé, Alberto.
Yes, my name is all right, so we are going to present the discovery of infrared light by Herschel. But first of all, I'm going to tell a bit about where are we from, as Andorra is not a really known country. As you can see, it is between France and Spain, quite small country in mountains. And now I made this small introduction. I'll let you with my friends, and I hope you enjoy it.
Hi everyone, I'm here to explain you a little bit about Herschel. I'm sure you all know about it, but he's a scientific born in the 15th November 1738, and he's known because he was a scientific, as I said. He also was an important astronomer and even musician. He's really famous about the discovery of Uranus, also the infrared light, and he worked on the structure of new light. He finally died on the 25th August in 1822. I'll leave you with Blake.
So I'll talk about the discovery of Herschel's discovery of infrared light. So how did he do it? He was doing an experiment on how the light spectrum affected the temperatures of thermometers when they're shown on them. And a specific thermometer was placed just beyond the red light of the spectrum, and that specific thermometer increased in temperature. This made Herschel realize that there is more to the light spectrum beyond the eyes of humans.
Hello. So we also recreated Herschel's experiment as best and as accurate as we could. And now we're going to show you a video, a little bit explaining you the materials and also the procedure we followed.
Some holes in it, a marker, and something. First, we make some holes in the shoebox to insert the thermometers. Then we take the four edges of the thermometers and paint it with a black marker. We take three of them together and left one apart to measure the outside temperature. Then we made a little hole to put the prism to adjust it to the thermometers, helping us put in some clay. Then we waited for a few minutes to see the results.
Okay, so the results confirmed Herschel's theory, since all three thermometers had an increase in temperature, providing the infrared light.
Hi everyone. Now I'm going to explain a thing or two about the light spectrum and how it works. So as most of you probably know, light behaves like a wave, and it's got two fundamental properties: the length of the wave and the frequency of the waves. Now these two properties are inversely proportional, and the longer the wave is, the less is the frequency, and the shorter the wave is, the more the frequency is. As you can see on the spectrum, short wavelengths with high frequency are, for example, cosmic rays, gamma rays, and X-rays, and the longest wavelengths, which means the shortest frequencies, are, for example, radio, broadcast, microwaves, and radar. And as you can see, the visible part of the spectrum is actually very, very small in comparison to the rest. And the infrared light, which was discovered by Herschel and confirmed by our experiment, is directly under, and the wavelengths are longer than the red light, which is why it's called infrared. And as you can see, it's located to the right of the red light. And this confirms our experiment.
Okay, so even though what we have said in our presentation is not something new for you, since we are all informed in this topic, I hope that you at least found our presentation entertaining, and thanks for paying attention.
Thank you very much for your presentation. Really, you work very, very well in order to prepare everything and coordinate with all of us, all of you, sorry. And then I think it is really a good presentation. Congratulations. And we hope that you enjoy the experiment. Anybody talk about their personal feeling about the experiment? Maybe some comments?
So when we did the experiment, although the conditions weren't the best for the experiment, considering climate and overall was fairly cloudy, we enjoyed it very much because it was fun. We had to cut up a box, we had to locate the prism, and it wasn't, of course, when you make this kind of experiment, you're faced with challenges, but it's part of the fun.
This is exactly that I want to listen. Thank you very much. Thank you for your contribution, for your work, and continuous making experiment and enjoying the science. Okay. Well, the next one speaker is from Spain, Juan Antonio Prieto, Colegio Huerta de la Cruz de Algeciras. Where is? I here. Wow. Thank you. I didn't see Juan Antonio, and I tried to find, and finally he's here. Right. Okay.
Hi.
Hi. Hello. Who is the first speaker? Because we have many people here. Hello, Pilar.
Hi, Rosa. Nice to see you.
Thank you. Okay. We have here the PowerPoint. Okay, thank you.
Good morning, everyone. My name is Silvia, and I belong to Huerta de la Cruz School, which is placed in Algeciras. Our presentation about Herschel's experiment, in which we have focused our efforts on infrared detection and its practical applications, it is going to be divided in 3 parts. On the first part, we are going to talk about the experience which we have been working during the school year. The second part, it is going to dedicate to Herschel's son. The third and last part, it is going to be about the practical applications of all the above. Now I'm going to make way to the students.
We have worked in Herschel experiment for several weeks during the last school year and the beginning of this year. In total, we have done about 20 experiments. To facilitate the task of recording those data, an Excel table was used so we could see how the temperatures evolved on the different days depending on the weather conditions.
We have focused your attention on the son of astronomer William Herschel. Sir John Frederick William Herschel was an English scientist and a botanical photographer. But what has caught your attention the most was his contribution to astrobiology by relating the heat radiated from our sun and leaf on Earth. He studied how heat allows the existence of living organisms. Similarly, he compared temperature generated by visible light and radiant heat. John speculated that heat helps all living organisms to survive, not only human beings. His experiment shows that the heat didn't come from within the organism, but from our sun, 70,000 billion kilojoules per hour. This enormous radiation was transformed into biomass inside of the plants. John Herschel also believed that the solar heat affected other aspects of the planet, like the changing weather. For John, natural disasters such as tornadoes proved that your planet was alive and had a good health. He compared the temperature generated by visible light and radiant heat using this graph. The red light emits more heat.
Practical application of all the above is the identification of terrestrial areas with healthy plants using the infrared detector placed on the artificial satellites Sentinel-2 and Sentinel-3. In this image, we focus our attention on the forest fire that occurred at the beginning of September 2020 in Sierra Bermeja, less than 100 kilometers from where we live. In this fire, more than 9,000 hectares were burned. The picture taken by Sentinel-2 has been processed by a combination natural color band photograph with images taken with short-wave infrared detector in order to make the fire front visible.
At the beginning of September, it was a massive fire in the south of Spain. Using the Sentinel-3 satellite, we can compare the image of this area before, during, and after the fire. On June 26th, before the fire, we can see two photographs of Sierra Bermeja taken with visible light and infrared light. We can observe if that region red and orange tones, showing that the vegetation enjoyed good health. You can see the image of Sentinel-3 during the fire. The smoke trail can be observed on the visible light photo. Also, we can see that previous shades of colors have vanished in the area where the fire is. Finally, these are images after the fire, specifically on September 10th. We observed that the burning area cannot be distinguished with the image taken with visible light. However, it is clear with the infrared one because there is a lack of healthy tones, red, orange, and yellow.
Thank you for your attention.
Well, thank you very much. I think this is very, very interesting, this study that you begins after the experiment of Herschel, and the fire in Sierra Bermeja was really very, very impressive. I would like to know if you can do some similar study with the problem that we have in our country in La Palma with the volcanoes or not. It is a different approach. I don't know. It is.
Yes, of course. You can also use the image taken by the Sentinel-2 and 3 to visualize the lava erupting from the volcano in La Palma. And that way you can measure the area affected by the volcano eruption. Yeah, for sure. Yeah.
Okay, this is a very interesting approach that absolutely different that we listen in the other contributions. Thank you very much. And I think that it is the moment to say good wishes for La Palma situation and for all the teachers that they are working there, and they work also with us in Ciencia en Acción and NACE also. Them, we would like to support them in from a cordial, from our heart approach. Okay, thank you very much for your contribution.
Thank you.
Thank you. I would like to introduce now the next one speaker is Salma Salih from Senegal. Salma, I saw you before. Here, Salma. Okay. Welcome, Salma. We don't hear you. Your micro.
Hello.
Hello. Now stop.
Yes. Okay. Thank you very much. Hello, everyone.
Thank you.
Yes, I am Salma Silambai from Senegal in West Africa, and I am a PhD student, and I am the National Outreach Coordinator for the Office of Astronomy for Outreach for Senegal. And I am very happy to work with Rosa and to participate to the experiment of Herschel with some students. And I will go to speak about our experience for the Herschel experiment. And at the beginning, we had problem to find prism, and after some discussion between Rosa, we decide to make our own prism. I go to show you. Maybe I can share my. Sorry. Select. Yes. Do you show?
Yes, yes.
Did you see? Yes.
Yes.
Okay. And you see here, and what we do after discussion with Rosa, we decide to make our own prism to have some glasses, some cutter and rulers, and after and water also, and we come to make the prism. And in March, at the beginning of the experiment of Herschel, we present our prism, and one colleague I want to thank a lot is French from Vienna. He decided to send us a lot of boxes to allow us to continue our Herschel experiment. And you see, after the artisanal prism, we have now a professional prism. Very big thanks to France. I think France is here.
It was here. I think that he have to leave.
I'm still here. I'm still here.
Yes,
Oh,
yes,
France.
yes.
Thank you very much.
Yes, thank you very much for the prism and for the thermometers, because also it was difficult to find in place thermometers. Yes, we continue. Yes, and with the material, with our students, we continue the experiments. And here is our team in Senegal for the Herschel experiment. Yes, here we are in teamwork. Now I am not with the students because, you know, now in Senegal we are in holidays, and maybe the next time the student will enjoy to be here and present their work. And with the prism, we are able to get the different colors of the light, and the students were very happy to see that the light is not white and the light is divided by many colors. They were very happy to discover by them. And I go to tell about the difficulties. For the experiment, we have some difficulties about the signal. Sometimes the signal were very low, and the weather also is not very better. Sometimes we have wind, and when we decide to go inside the signal is always lower. And another problem was how to fix the thermometer in the different color in the box. It was very difficult with the students to do it. And the other problem was after to fix all, the end was to take the value for the different colors. But every time we have the same value, the temperature for the color is not changed. And and in the future, we would like to continue and to improve the experiment. And I thank again Rosa and all the team for the nice organization, for the Herschel experiment. It is very instructive for the students. It is very exciting, very interesting, and thank you very much. And I am happy to be here with you and to learn a lot about the other groups. Thank you.
Thank you, Salma, and congratulations, because your effort was absolutely important in order to organize this activity. I remember when you explained to me that you didn't find one prism and you begin to prepare one yourself. I think that from my point of view, congratulations. This is exactly that the students need to see. One teacher that has a problem and find a solution. And also the help of France was absolutely very, very important. And I don't know, but I would like to suggest that if you put the prism and the paper for the colors close, maybe the colors are, the signal will be more strong and you can obtain a different temperature. I don't know. You can try to do it, okay? Okay, thank you very much. And
nice.
congratulations, because you are a strong woman, and in the world we need this kind of women. This is clear. Thank you very much.
Thank you, Rosa.
I would like to introduce the next speaker is Paraguay, and Jose Maria Gomez. That here is Jose Maria. Good morning, Jose Maria.
Good morning, Rosa,
for you.
and everybody.
It is difficult. What hour is in your country now?
Right now it's 6 a.m. It's a little early, but it's fine.
Fine for
I
poor.
usually wake up too early. It's fine for me.
Well, this is the reason that we
Well, I
organize
want
the session
to share my
according to
screen, Rosa.
longitude, in order to try to begin with Asia. All the people in Asia is sleeping now, probably because it's very, very late. And after Europe and Africa, and then America, in order that the hour will be not so bad. Okay. Thank you, Jose Maria.
Okay, Rosa. Okay, I want to share my screen. Yeah. Well, it's a pleasure to be here sharing with all of you. I'm from Astronomical Observatory, Professor Alexis Cloche, in San Lorenzo, Paraguay. We are in South America, around 25 latitude south and longitude 57 west, right here between Brazil and Argentina and Bolivia. Well, here at the experiment, we use a prism thermometer, and it was not easy because we had many days cloudy before in September, and just one day, a sunny day, and we made the experiment in the observatory. We have a movable roof, and we use that to get a shadow in one part and the sunlight in the other. And we made the experiment. The one is not easy here in Paraguay. Is too hot, but we have some interesting results. Here is the environment temperature it doesn't change around 5 minutes. The blue light show temperature increasing around 31 degrees. The infrared light, the most important in this case, was increasing and got around 34 degrees in 5 minutes. And the yellow light increased more yet, and like this. They are results. Our conclusion: we observed the infrared radiation. The experience is very good to use in project with students of high school. We could to improve the design of the experiment to use with first year of science students. Thanks to all.
Thank you very much, Jose Maria. I understand that you do the experiment in the observatory, but without the students, because probably you have COVID problems also.
Yes, there is. We have a rule made easier to do the experiment. We made the experiment with the weather was so close all September. That's one day of sunny day, and we used that day to make the experiment. We made the experiment with professor, Department of Science faculty.
Okay. Excellent. Thank you very much
Thank you
for your effort. I know that the COVID is a situation in our planet that probably continues some years more, but in any case, we can see that the people continues working and preparing activities and to work with the students, and when it's possible and when it's not possible, then begins to prepare in order to be ready for the next one occasion. Okay, the next one speaker is Argentina. Thank you, Jose Maria. From Argentina is Beatriz Garcia. Hello, Beatriz.
Hola, Rosa. Hello. Okay, well, how are you, everybody? Hello, hola, aquí from Argentina, South America, very near Jose Maria. Well, it's a pleasure to be here, and I would like to share some experience with my own students. Let's see if I can select the window. And as you know, we are coming back to the schools in the last weeks. So it was possible to, I don't know if you are sharing with me the screen, I hope.
Yes.
Okay. I would like to remember that William Herschel was part of a family where the science was one of them.
We lost the PowerPoint.
Sorry?
Disappears. Sorry, I don't see now.
Disappear. Well, I don't know what's happened.
No, now it's again. Wow.
Well, I changed everything, so I will try to share again.
Go on back. I don't know.
Can you see now the presentation?
Yes.
Okay.
Yes.
Okay. Let's try in this way. Well, I said that the Herschel family was an amazing family, not only devoted to the science, but also to music. So I would like to think that not only William was part of this experiment, but also Caroline Herschel. And I would like to share a part of this life sharing by the son of William Herschel, who detailed that New Year of 1840, the whole family sing a song near the 12-meter tube telescope, reflector telescope, made by this family. And in this amazing family, the science was part of life, not a job, was part of their lives, and in a someday probably, and along many days, they performed a lot of experiments, and finally they discovered that beyond the light, beyond the red light, there was more things, and these more things are more light. The difference is that our eyes cannot see it, but the infrared is part of the radiation of the stars and arrive from the sun, and is one of the most amazing experiments to be performed in the classroom. Here you can see some part of the bodies of my students preparing the experiment in the yard of the school, and taking notes and installing thermometers and having these kind of tables, because we are trying to work not only with the computers and with the cell phones, but also in the original way with the pen and paper. And this is part of the activities that you can make outside the classroom. The science is everywhere, the science is outside the classroom, and the science is part of our life. We detect the infrared, we were part of the amazing experiment, and now I am here representing my great students, which are again in the class, again in the school, and well, demonstrating that the science is part of the big activities of the culture, the human culture. So, received from Argentina my own greetings, but the greetings from my students here, very happy, because we made almost all the experiments outside. Mid-June was Eratosthenes experiment, now is Herschel experiment, and very, very soon will be Bunsen experiment. So I invite all of you to be part of this big family, the family of the science in the world, and the family of the great activity, the friendly activity, which is the science. Thank you very much, everyone, and I give my space to the next speaker.
Thank you very much, Beatriz. Wonderful presentation. The next one speaker is from República Dominicana, Adrián Torres. I don't see who is Adrián. Hello. Is not here. República Dominicana. Adrián. Well, then I will pass to the next one speaker. If after appears Adrián, we can take the session, okay? Well, the next speaker is Valeria Buenrostro from Sweden. Valeria is not here also. Wow. Valeria. Okay. I asked for all the people that will be 10 minutes before, but 10 minutes, not more. I don't know if Venezuela is here. José Antonio Mora.
José Ángel. José Ángel. Here.
Hola. Hola.
Hola.
José Antonio,
Hola.
no, José Ángel. Perdona. Sorry.
José Ángel.
Sorry, José Ángel. Thank you very much to be here, to be before that your turn, and thank you for your presentation. And when you want, you begins.
Well, thanks a lot, everybody, to be here. My name is José Ángel Mora Robles. I am from San Cristobal, Venezuela. Thanks for everybody to be here. We have the chance and the opportunity to experience the infrared light as the way Herschel did. I knew the experience also the Ritter experience when they discovered the infrared and the ultraviolet. So we did the experiment using alcohol and thermometers because we are interested in the visibility more than precision. So we want, I wanted to take the readings without disturbing the setup and to avoid the children to move to take to disturb the experience. So we use a glass prism and was astounded to see how the thermometer in the shadow in the far from the red took a higher temperature. So we are really pleased to did the experience because we are in the tropics and the weather was very cloudy. One day the sun appeared between the clouds. We had the box and the thermometers ready, so I did the experience in the afternoon. So we experienced the infrared light using alcohol thermometers to be able to take the readings without touching the boxes. Thanks a lot to everybody.
Thank you very much for your presentation, Jose Angel. I would like to know, because you sent to me a picture with with a full family, no? A grandmother, children, and what is the impression for the difference of between the opinion of the grandmother, the small children, the teenagers? That are similar or they have a different approach?
All of them were amazing because they were in a class, in a color class, in an arts class, and they were talking about color. When the sun started to shine, and I asked, come on, see the sun, see the colors." And was really amazed everybody from the child to the grandmother because they were talking about color, they were painting, they were talking about the how do you say in English, the colors, the matching colors, the opposite colors, the primary, the secondary, and then we see when they see the colors in the bottom of the box, then they all of them, from the child to the grandma, they were amazing. Everybody.
Wonderful. The sign is exciting. Okay, thank you very much. Well, the next speaker is Valeria Buenrostro from Sweden. Hello, Valeria.
Hi, Rosa. Hi, everyone. Can you see me? Can you hear me?
Yes, very well.
Perfect.
No problems. Thank you.
Yeah, so I did the experiment with a 4-year-old boy.
Yes.
He didn't understand everything, but he was very excited because it's the first time that he was doing an experiment, a scientific experiment. He was really looking forward to it. I told him half an hour before that we were going to start this, and he wanted to look at all the thermometers and the prism. He had never seen them before. We used very, very long thermometers about this size. And he was very interested in looking at the numbers, first of all, and then he saw that there was this blue line inside of it. He didn't understand what it meant, but when we started doing the...
It looks like we lost your voice.
Can you hear me? Yeah.
Yes, now yes. Yeah.
What excited him the most was the prism itself, because he had never seen one. And when he saw the colors on the box, he said, "Oh, look, it looks exactly like a rainbow," because he knew rainbows very well. So I had to explain to him that it was exactly the same, like how rainbows are formed, and you can see all the colors because the water is like a prism. So this is a crystal prism, like in the sky, but crystal. And here you can see all the colors. And then we put each one of the thermometers in the different parts, and he started to see how the lines were increasing. And he was just smiling all the time. He didn't understand the difference between temperatures, but just looking at the box with all the thermometers and the prism and seeing the colors and the lines increasing, he was really, really excited. So I think it was a lovely experiment, even for such a young boy. So we will keep doing experiments like that.
Excellent. This is good. The first contact with science is positive. This is very
Exactly.
important. This is very important. And after he can remember this in a positive way, and probably science is not bad for him.
Exactly.
Well, thank you very much, Valeria, for your participation and for carry out the experiment with the children. Okay, thank you. And the next speaker, I hope that will be here, the República Dominicana, Adrián Torres. I don't know, is connected or not. I think not. Okay. We will continue with the next speaker is Paulino Garcia Ramirez from Mexico, Universidad de Guadalajara.
Okay, I'm here. I am Juan Garcia Ramirez.
Thank you very much.
I'm
Thank you.
his brother.
Welcome.
And we do the same. We work together.
I'm sorry because it's very early for you, but well, it's impossible to find a good period of time for all the world. It's not possible.
Okay. But I'm here, and I'm very glad to be here with you to share something about the activities. In this case, with the experimentation of Herschel experiment, a very, very interesting experiment with many situations, with many emotions, with many. I can name all of the situations. Let me do something. Let me do something because the light is giving me some problem. I guess it's better now.
Okay.
It's better now.
Find
Yes.
a good position. This is good. Okay.
Thank you, Rosa Maria. Well, in this case, what I had to do, or what I would like to explain, is the process we live in our school. We have been working there since 25 years. So the experience for us is emotional, is magnificent, is, I don't know, working with students involved in the experimentation and researching is something very, very interesting. The student gets involved with the process. It's not easy. Not many students want to do that, but I guess the main situation that we have to take in count is that if you get one student, two students, three students involved with these activities, you won a lot of opportunities to transform really their lives. The experience with experimentation in this case began with a question: why there are different situations with heat? Okay, let's discuss. Let's prepare the experiment. Let's do all of the activities following a method, following a process, following the scientist experimental method. And with that, the students got all of the materials, improvised some of them because we didn't have many opportunities to get all of the materials we wanted. But when they finished preparing all of the activity, we did with him, and immediately we went to do the process. And it was very fascinating because they were discovering all of the process.
Hola, us toca ara ja, eh?
I'm sorry?
Ah, no, per què no? No teniu cap Gmail?
I'm sorry, Rosa Maria? Oh, I can't hear you. Okay.
No, go out. Avanzar porque simplemente que atendió el teléfono, Rosa.
Yes, sorry, I have the next speaker that cannot enter in the session. Cristina, could you
continue.
give permission? Sorry, but there are some situations.
No, everyone know that you have a phone call.
Yes, thank you, Juan.
Thank you, Rosa Maria.
I was trying to answer the person that have to the presentation now because he cannot enter in the session. Then I hope that Cristina give the permission to Esther Pinto. Okay, thank you, Cristina.
Okay, thank you
you,
very much.
Juan, for your contribution. I absolutely agree with the comment that you say about the young people and science and education. This is absolutely true, but in some cases it is difficult to manage. Okay, thank you.
Greetings to everyone. Greetings from Mexico. Bye.
Thank you very much. Thank you very much from Mexico. And the next speaker, I don't know if connected or not. Cristina. What is Cristina?
No tengo ninguna solicitud todavía de Esther.
No sé. What is the problem? You can call her or something like this, and you try to solve. In any case, I would like to invite a couple of minutes to Iran that I saw that they can recuperate the connection. And we have 3 or 4 students here from Iran. And I don't know who is the speaker.
Hello, dear Rosa. I'm Hassia Dayat from Iran.
Okay.
Now I'm available and I have internet connection to share our experience with you. I'm glad to be here.
Okay, then explain very shortly, very briefly, your experiment because you are in the time of other presentation, okay?
Okay, thank you very much. Okay, in the last hot days of summer in Boucher Province, my friends and I were each interested in astronomy, decided to repeat Mr. William Herschel's infrared detection test to understand better the presence of the infrared radiation. We did this project twice. Our first test, which done on September 9th, was about an hour before sunset. Then we encountered with some problems such as low sunlight and improper angle. But we didn't give up, and in order to achieve a better and more accurate results, we decided to try it again in the next day. So in the next day, we do it about 3 hours before sunset. And the experiment was conducted with gentle and hot summer winds. Finally, we were able to feel the presence of infrared light more than ever. The air was very hot and sultry, and breathing behind the masks was very, very tiring. And but the warmth of our love for the science, and the better knowledge of the universe is greater than that. And thanks for your attention, dear Shahzad. Now the floor is yours.
Thank you. As my friend said, that was so very hot, and actually we were boiling, but we have some good memories too. The best present that this project gave us was our friendship. Actually, when because of this project, we met each other and become our best friends. So we go to the observatory, Meh Observatory, and do this project twice. And at night, even we sight the planet with telescope, and that was awesome. And I want to say, at the end, do you know what make us special? Our teachers. I know all of the teachers in the world are best. They have a good points, but there is something special about our teachers. They work hard and they never let us to feel shortage about something. So we are very thankful and proud of what we have. Thank you.
Okay, well, thank you very much for your presentation. I know that you had difficulties with the internet connection, but in any case, you have finally a short presentation for us, okay? Well, now...
Even my PowerPoint, we can share it because we have lots of picture about this project, and I don't know why.
We don't have time.
I
Sorry.
think it's okay right now. Can I share it now?
I have another speaker here. You have 1 minute, okay? But no more, sorry.
Okay.
It's just picture.
1 minute only.
Is it okay now?
Yes.
Yeah.
These are the pictures, okay?
Yes.
Okay, I know these pictures because I received practically all of them.
And finish.
Okay.
Thank you for your attention.
Okay, thank you very much. Thank you very much. And I don't know if we have the last connection. We have here Jose Maria Perelló.
Hello, how are you?
Okay.
Can you hear me properly?
Finally, yes. I would like to introduce a little bit Jose Maria, because this is a different presentation. This is not a Herschel experiment. This is the presentation of one secondary school in Spain, in Lleida, that this school is embassy center of our organization of NACE Embassy Center. Then I would like that he explained that what is the structure of the contents in this secondary school related to astronomy, in order to motivate that maybe other places in other countries, other schools could be interested to be also NACE ambassador centers. Then you can contact with us and to explain what you are doing. Okay, then Jose Maria.
Yes. So, hello to everybody here, and then our center is Instituto Revisens. We are a secondary education center in Lleida, that is in the northeast of Spain, just 150 kilometers away from Barcelona, and we are a big school, about 1,400 students in our school, more or less 60% in vocational studies and the other 40% in secondary education, and about 130 teachers. So our goal and objectives with NACE, being an embassy center for NACE since the 2021 course, so it's about a year and a half or so. So it's basically to use the NACE tools to join projects multidisciplinars, joining different areas and subjects. So we have here a strong mentality focused towards STEAM studies, so including science, technology, maths, and many other subjects, including arts and social studies. And so for us, the key point is motivation. Motivation of students, motivation of teachers, in different projects in which we mix different areas, social studies, mathematics, technology, etc. So I would remark two projects, and we have several of them, but those two for us are the basic one, the core ones. So the first one is the Solar School analytic clock that we have. So we have a clock in which the students can stand in front of the clock, and the student, the body itself of the student or the teacher is the one that points the hour that is going on that time. So we did that with our students and teachers, and also other teachers from other schools in the area, in that kind of purpose of being ambassadors of NASA. So that's one project. The second one is the solar tracking. So in this one, what we did is different times along the year, we had a kind of panel in which we could track the daily trajectory of the sun all the day long, since the sun rises in the morning until the end of the day. So using this
We have difficulties in the sound. It's not possible to hear you. Jose Maria. Sorry. Well, I think that basically you catch the idea that they organize all the activities in the school connected with one important axis, that it is astronomy, because astronomy really is a STEAM. Then it is possible to mix with all the subjects and to work together. We lost your voice, but I think that you explained very well the idea. And if you agree, we finish here because we have another connection now, okay? Jose Maria, you have something crucial to say? It's okay?
Thanks so much for your attention, and motivate, please, your teachers and students with the NASA tools, because they are really useful, and with very low budget and materials, you can do a lot.
Thank you. Thank you very much, Jose Maria. Thank you. Well, the next speaker is Marina Rodriguez. We connect again with the Observatorio Astronómico Nacional because they have two Herschel telescopes more that they want to show to us. And also we have the opportunity to know more about what William and Caroline what area work in astronomy. And then we have here again Marina and Miguel, and then we are waiting for your presentation, please.
Hello again from the Spanish National Astronomical Observatory. In this case, we're talking to you from the front of our main building. We wanted to show you this building a little bit, and now we are going to enter inside to show you a little bit the little telescope, as you say. But I wanted to tell you while we walk, I tried that you can hear me, that this building was built in 1790. The architect Juan de Villanueva, and as I say, it's the main building of the observatory. Now, when you enter, you will see that when we enter, you will see that we have some old instruments here. I will show you. Now, the acoustic is not going to be very good for a moment until we enter the library. This is our some of the old instruments that we have here. I hope you can see them, and come with me to the library of the building. That is also a very old and very beautiful library. can see it on the other books. And if you come with me here, at the end of the room, we have the two small telescopes, the original ones made by William Herschel and his sister Caroline, that were sent here with the big one, the one that I will show you before. As Rosa Maria said before, what we wanted to tell you about now is about the things that the Herschel siblings discovered with their telescope, the things that they were able to find out in the sky. But before that, we are going to tell you a little bit about them, about William and Caroline. You have them here. Images. This is William. William, as you may already know, was born in Germany, but he spent most of his life in England, in Great Britain. He came from a musical family, and when he was just 19, his father sent him to England along with his brother. He was very, very talented. He was able to play violin, the oboe, the harpsichord, and even later the organ. During his first years in England, he traveled across the country trying to find a good position as a musician to work there, until he was able to settle down in Bath as an organist, with a very good position as an organist. He was also a composer, and he composed very good symphonies and pieces for the organ. So paradoxically, it wasn't until quite late, until he was in his mid-30s, that he was interested in astronomy and started studying astronomy and also building their telescope. For a long time, he thought that he will be remembered as a good composer, musician-composer, instead of as one of the greatest astronomers of all times.
Caroline, who we can see here, was William's sister. She was not as famous as William was, because at that time, and often still nowadays, it is more difficult for women to become famous as scientists. But she was a really, really fine astronomer. She had also been born in Hanover, in Germany, and she followed her brother's footsteps, and she also moved to England quite early on. They both lived together in Bath for quite some time. At that time, William was...
Normalment no hi ha preguntes.
William at that point was a musician, and she was also one. She sang, she was a sopran. Then when William became interested in astronomy, she also started learning astronomy, and she made really good discoveries in astronomy, as we will see next. For these discoveries, she had some good recognition at the time. As a matter of fact, she was the first woman who got paid for doing astronomy in a systematic way. She got a salary from the crown in England, from the King, George III, for her work as an astronomer and for being the assistant to William. In addition to this, she also won prize from the Royal Astronomical Society, Golden Medal, and she became the first woman who was an honorary member of the Royal Astronomical Society, which was a very important institution back then and still nowadays. So, as we will see now, she definitely was a great astronomer, the same as her brother was.
Yes, and now let's go to the astronomy that they were able to do. The things that they were able to discover with the telescope that they built. To begin with, we all know nowadays that there are 8 planets orbiting the sun. Ours, the Earth, another 7 planets orbiting the sun. But at that time, the time at which they were building telescopes and observing the sky, only other 5 planets were known. Those that were known since antiquity, and they were visible by naked eye. I mean, Mercury, Venus, Mars, Jupiter, and Saturn. But in 1781, William Herschel became world famous because he discovered a new planet orbiting the sun. It is Uranus, the 7th planet orbiting the sun. And he did so using one of his own telescope that was very similar to those that we have here, that, as I said, are the original ones. So they are more modest than the one that we saw before, but they were also very powerful, and he was able to discover Uranus with one of those. As you can imagine, this was a revolution in the world of astronomy, to suddenly prove that there was another planet after all the time where people thought that there were only 6. In the words of another astronomer of that time, after this discovery, William Herschel became the most celebrated astronomer in the whole universe. Interestingly enough, the name of Uranus that we use today is used only since the middle of the 19th century, because after the discovery, William Herschel proposed a very different name, Georgium Sidum, that is in Latin and means the Georgian star, the star of George, and it's named after the king, the English king at that time, that it was George III, and it was named after him in his honor. But this made the king very happy, and in fact, he granted William an annual salary of £200 as a king astronomer because of that. So it was a very good idea for William. But after that, after a few decades, the name of Uranus was established, and this is the one that we use today.
So these great discoveries were possible as a result of the great ability of William, and also probably assisted often by his sister Caroline, to polish mirrors. As we said before, in a reflecting telescope like the ones that we have before, the light will travel through the tube all the way down to the bottom, where it encounters a concave mirror that reflects the light back and allows you to form the image. William spent months and months, often even years, polishing these mirrors to absolute perfection. And this is what allowed him, and also Caroline, to make such new discoveries. As we mentioned before, the great telescope that was built for Madrid was unfortunately destroyed during the Napoleonic Wars. But luckily, before the troops arrived in Madrid, the astronomers were able to hide the maps, these drawings that we saw before, which allowed us to make this reconstruction of the telescope, and also the primary mirror, which is the most important piece of the telescope. In that sense, what we're going to show you now is probably the most important historical piece that we keep in this museum. Come with me. This is the original mirror polished by the hands of William Herschel during several months at the end of the 18th century to absolute perfection. When William saw the image of Uranus reflected on this mirror with this telescope that he built for Madrid, he said that it was the very best image that he had ever obtained of Uranus. In fact, you can see the mirror is almost flat, and this is because it was associated with a telescope that had a focal length of 25 feet, very, very large. Let's move back. The acoustics here is a little bit better. So with such mirrors, he also constructed similarly large telescopes in England, a few of them. Specifically, he constructed a 20-feet telescope with which he was able to discover the two largest moons of Uranus. So not only did he discover a new planet of the solar system, he had the intuition that this planet also probably had satellites revolving around it, and indeed this was the case. Not only this, he measured the time that it took the satellites to revolve around Uranus, and he was able, with this large telescope, to resolve the size of the planet. He could measure how large it was. Combining this information, he knew the volume of the planet, and from the orbital period of the satellites, he could deduce the mass just from Newtonian mechanics. This allowed him to calculate the density of Uranus. It turns out that Uranus is 15 times larger than the Earth, but it turns out the density is way lower than the one on the Earth. That's why Uranus, together with Jupiter, Saturn, and Neptune, forms the outer planets of the solar system, which are called giants, gaseous giants, whereas the rocky planets that lie closer to the Sun tend to be much denser.
Planets are not the only bodies of the solar system that the Herschel siblings were able to study. With their telescopes, they were able to identify many other bodies that were unknown until that moment. And an example of that are the comets. Caroline Herschel was the first woman to ever to discover a comet. Comets are those bodies that are made of rock and ice and that are orbiting the Sun with very elliptical orbits. Sometimes we can see one of them in the sky from the Earth, like in this image, and they are very beautiful. You can see the beautiful. This is a picture from a couple of years ago. This is the Neowise comet. But this is an exceptional case because most of the comets are very difficult to detect because they are much fainter than planets or the visible stars. So many of them were unknown, and Caroline Herschel was able to discover with her own telescope a total of 8 new comets. It was very much because of that. The first of them was discovered in 1786, and because of that, she was granted an annual salary from the king. An annual salary of £50 per year, less than her brother. This is a gender gap in the salary, but well. But she became as we said before, the first professional women scientist in history. So it was a very important challenge for her, and she managed to do that.
So one of the most important consequences of building such great telescopes was that the Herschels were able to see much further than ever had been able to see before. In particular, they could prove astronomical objects beyond the solar system. They saw very faint stars, and this allowed William Herschel to build the first map of our galaxy, the Milky Way. Because we are embedded in the disk of the Milky Way, it is very hard to know which shape our galaxy has and how large it is. This is similar to what happens when we're in the woods, right? We can see the trees with great detail, but we cannot see the whole structure of the woods precisely because we are inside. We cannot see the woods for the trees, the forest for the trees. But William gave a first try to this, and it's really admirable. This is his drawing of the Milky Way. He placed the sun in the middle because as a result of the absorption of dust, we do not see the stars that are really far from us in certain directions, but indeed it's a first attempt. And he did this in a scientific way by counting how many stars exist in a given area of the sky. He surveyed a total of around 600 areas in the sky with a telescope, counting how many stars he could see in each direction, and therefore projected the visibility of the Milky Way in different directions. Now we know that the Milky Way is a spiral galaxy that has a shape of a disk, and we know that we are not at the center of it, but still this is a really admirable first attempt at this very difficult task.
Well, those were some of the main examples of the things that the Herschel siblings were able to discover with the telescope, with the amazing work that they were able to do. Everything that they did was done thanks to the curiosity they had, their determination, and their relentless work. The same way that our students are working today on our experiments. So the Herschel siblings were the greatest scientists of the past, and maybe our students are going to be the greatest scientists of the future. I hope you have enjoyed the visit with us, and I hope that we can meet you soon here. Thank you for your attention.
Thank you very much. Thank you really for your both presentations, to share with us your telescopes. And thank you for this short presentation about the overview of what both Caroline and William, they learn and show us about astronomy. Thank you very much. And we are in the last part of this connection. We are really to finish, and I would like to share with you one moment. I will try. Yeah. I hope that you can listen the music of Herschel, William Herschel. Could you listen? Okay.
Yes, Rosa.
Then I would like to thanks to the Observatorio Nacional, to Franz from Vienna, for his wonderful presentation, very motivating and very interesting. And I would like to thanks to Vilma from Lithuania and her students, small students, that they work very much in the experiment. Also to Sheila from Philippines, that I know is raining continuously and had serious problems to get the observation. To Samir in the same situation. And also thank you very much to Indonesia, Ishan, that it was a good presentation. Don't worry for the language. The more important is to communicate, and you communicate very well. Thank you to the students of Margarita and Dina in Greece. The presentation was very good. Thank you to the students in Iran. We have many of them. I know that they work strongly. I would like to know how many students involved in total, because I received maybe 20 or 25 different experience in different parts of the country. Thank you to Jibaji from Tanzania for the contribution in these countries that I know it is difficult to find some devices. Thank you to Ivo from Bulgaria that has serious problems in the connection, but well, you know that the technology in some cases is that. Maria from Romania, thank you very much. We have many contributions from Romania. There are a big group of teachers working. Thank you to Tunisia. Thank you to Sarah for La Cité de la Science. Thank you very much to Margarita, Maria, and Ildio from the Planetarium of Porto. Also, thank you very much to the contribution from Germany, from Beate. And I hope that next year can begin to work again in the school. There are other teachers in Germany that they cannot participate because they were in the school. Thank you to Carlos from Andorra and all the students from Andorra that explained to us many things about Herschel and also about their country, a small country, but very, very beautiful. Thank you to Juan Prieto from Spain, and also to Salma, that I know in Senegal, in some cases this is difficult to carry out the activities of NACE. Thank you to Paraguay, Jose Maria from the Observatorio Alexis Troche. Thank you very much to Beatriz, that he is one of the most important people in NACE projects. Thank you to our colleague from Sweden, also as member of NACE from Valeria. Thank you very much to Jose Angel Mora from Venezuela, that explained us with a lot of interest what he prepared with the family and with the students. And thank you to Juan Garcia from Mexico, that explained to us the activity that they do it, and also the application of the possibly results for the young people. And finally, thank you to the Torre Vicens from Lleida, the NACE ambassador secondary school, that I hope that will be a good suggestion for all of you. We invite that you believe that it's possible to create one structure in one school pointed on astronomy, and astronomy is an STEAM basically concept, and then it is possible to introduce astronomy in all the parts of our life if we want. Then thank you very much to all of you, and I promise you that we continue with next year new projects. I don't know what, and if in any case, if in this moment I know, I don't say, because I said you before that this is also always a secret, but really we are thinking about this. But I think this is a wonderful opportunity to exchange information, to see our faces. I am Mediterranean person, and for Mediterranean, the face of our friends and all the people that we know, it is very, very important. Then thank you for participating in this meeting, and see you again in the next meetings of NACE in the future. And bye-bye to all of you. Thank you.
Bye.
Thank you.
Bye. Goodbye.
Bye-bye.
Put all the cameras saying, all the cameras saying bye-bye.
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 Bye.
Bye.
Bye. Thank you very much.
See you again. Okay.
See you soon.